Okay, I hear the recording in progress, so I'll share the screen. Right, so we are here. We actually have plenty of time. So 4.2, buffer day on Thursday, buffer day on Friday, which more than likely means I'll keep going and do more stuff in case I fall behind later. Okay, reminder, tomorrow is a sort of a holiday. I mean, it's a CSM holiday. It's a flex day. Teachers have meetings, but you don't have to come to class. Not just my class, but if you have any other class at CSM, you don't have to attend that either. So it's a one-day weekend, as I sometimes like to call it. And we will meet again on Thursday. Okay, so I'll try to knock off as 4.2 as I can. But if I don't finish it, I'm okay for Thursday even. Yes, question.
I was just looking at the syllabus, what you're pointing at right now. 4.9 isn't listed, but we are doing it, right?
4.9.
Yeah, it goes to 4.8 and then it doesn't list 4.9, at least on my document that I look at, I'm looking at like right now.
And you're probably right. I've probably neglected. Yeah, we have 4.9 in there. So it looks like that's going to be over here somewhere. Yeah. So,
okay, just making sure that we're doing it. Okay, thank you.
Yeah, we're still doing it. Yeah. So I goofed. So maybe I'll sneak it in here. But if I have extra days, I'm going to go ahead and go through it anyway. But yeah, thanks for pointing that out. Okay, so let me continue on with where we were last time. All right, so last time we left off with stuff like this. How do you do something like 25 and 27? They give you some coordinates and they ask you to find the coordinates of some other funny point. Okay, so 25 and 27 are similar. I'll show you how to do 25. And then let me give you the idea. It says P of T is 3/5, 4/5. This is a point on a unit circle, as it turns out. So T is an angle. Here's 3/5, 4/5. This is 1, 0. Okay, so this would be the angle T. This is the angle negative T, for instance. Okay, so if this is negative T, this would still be positive, but Y would be negative, right? So P of negative T would be 3/5, negative 4/5. Okay, so you can think of T as an angle. Angle is T. X coordinate, Y coordinate. And by the way, that's cosine of T, sine of T, or you can use theta. We'll use theta later. Theta for an angle. Okay, so part A, P of T plus pi. T plus pi, pi is 180 degrees. That lands you over here. I'm in a third quadrant. Well, if I'm in a third quadrant, both X and Y are negative, you might recall, for a third quadrant angle. So P of T plus pi is negative 3/5, negative 4/5. They're both negative. Okay, P of negative T, well, I just did that. Here's T, here's negative T. So what about this point? It has the same X coordinate, right? Same distance away from the Y axis, but the Y coordinate is negative. So this would be 3/5, negative 4/5. C, T minus pi. Well, that means I subtract 180 degrees. Well, I land in the same spot as T plus pi, right? If I add pi, which is 180 degrees, I end up here. If I subtract pi, I still end up here. So the answer is going to be the same as A, negative 3/5, negative 4/5. And finally, D, negative T minus pi. Well, here's negative T. It's 180 degrees off of negative T. So that'll land me over here. which is the second quadrant. What do I know in the second quadrant? X is positive. Oh, sorry, X is negative. Y is positive. So X is negative, negative 3/5. Y is positive, still 4/5. Okay. So that's all you have to do for 25. And 27 is similar. The only thing about 27 is they give you some funny square root thing. And they start off with X being negative and Y being positive. But I think you can still figure it out. Like I think it asks pretty much the same questions. You know, t plus pi, negative t minus pi, and so on. Okay. So that you figure that out on your own. So I did 25, you try 27. And then the last part of 4.2, and then we were done with 4.2, is the arc length formula in the area of a sector. Put these on your next formula sheet. Okay, so here's a derivation. I alluded to it last time. Okay, so arc length, a fraction of the whole circumference. So if I walk in a circular path, it's an arc, like so. So how far is it if I walk from here to here? Okay, so if I go all the way around a circle, circumference is 2 pi r, the whole circle. So if I start here, I walk all the way around, right? And I end up back here. How far have I walked? Well, I've walked the circumference of the circle, which is 2 pi r. Okay, so what if I only walk a fractional amount? Well, it's a fractional amount of the whole. So if I walk theta out of, if you're doing it in degrees, it's 360 degrees, but we're in radians, it's 2 pi. So the fraction out of 2 pi is theta over 2 pi, fraction of the whole circle. Multiply that by 2 pi r. Very conveniently, the 2 pi's cancel out. So I just have S is equal to r theta. Okay, so here's the formula. For arc length, how far did I walk along a circle? S, which is arc length, is r theta. Key thing though is that theta must be in radians. So if they give me something that's in degrees, you have to change it to radians. Of course, if it's already in radians, just leave it alone. So S equals r theta. And here's a derivation for the area of a sector. It's like a piece of pie, piece of cake. If I slice starting from the center, it's got to be from the center. So if I cut from here or something, you know, most of us, when you cut up a pie, you don't do that. You normally start at the center, right? But I guess you could just cut like that. It's kind of weird, I guess, if you cut like that, or you decide to cut like that, right? Most people who cut decide start at the middle, right? Start in the center and then cut outward. So we have an area of a sector. So you cut, it's a piece of pie. So what's the area of that pie? So again, I take the formula for the area of a whole circle, pi r squared, and then I multiply by the fractional amount. Okay, so if I go all the way around, it's 2 pi radians, n goes theta. So the fractional amount of the whole circle is theta over 2 pi times pi r squared for a sector. Pi's cancel out. So I have 1/2 r squared theta. So put this on your next cheat sheet. The area of a sector of a circle, 1/2 r squared theta. Once again, theta is in radians, so they give it to me in degrees. First, you have to change it to radians. Okay. All right. So I'm going to show you some problems involving that. Okay, and again, ignore any dates. So 180 degrees is the same as pi radians. That's halfway around a circle. We can use that as a conversion factor, right? So this is pi. This is the same as 180 degrees. This is 2 pi, 360 degrees. So if I take this equation and divide both sides by pi radians, 180 degrees divided by pi radians is 1. But if I decided from the get-go to divide by 180 degrees, it looks like this. 1 is equal to pi radians over 180 degrees. Notice this fraction is equal to 1. This fraction is equal to 1. And so which one do I pick if I convert from degrees to radians? You just make sure that the degrees cancel out or the radians cancel out, as the case may be. So one of them is on top of a fraction, the other is on the bottom of a fraction. Okay. All right, so here's a quick summary. Here's the picture. S is r theta, S for arc length. Area is 1/2 r squared theta, theta in radians. Okay. So problem 29. Theta is 45 degrees. Radius is 8 meters. First change this, 45 degrees times pi over 180 r. So how do I know it's pi over 180 and not 180 over pi? If I put 180 over pi, I have degrees and another degrees on the top. I have degrees squared. I don't know what's a degree squared, but if I put the degrees in the bottom, right, then degrees cancel out. I have my units of radians. If 45 goes into 180 4 times, so pi over 4. And hopefully you recognize that angle from your trig when you had trig, right? Pi over 4 was 45 degrees. All right, so now I can plug in. S arc length is r theta, 8 times pi over 4, 2 pi meters. This is considered the exact answer. Exact answer means leave it as pi. Once you punch it in a calculator, you only get a decimal approximation. So hence the squiggly equal. Have you seen the squiggly equal? Squiggly equal means approximately. So 6.28 meters. Right, so that means if I have a circle whose radius is 8 meters, okay, and I walk along a 45-degree arc, so how far did I walk? 2 pi, or 6.28 meters. Okay, that's all. It's not really that big a deal. 33. Theta is 250 degrees. Radius is 4. Let me show you the actual picture. Find the length of the arc in the figure. They told me this is 110 degrees. So the angle that I want is this, right? If I go all the way around a circle that's 360, they tell me this is 110. The arc that I'm walking across is more than halfway. I'm going all the way here. So it's 360 minus 110, which is 250 degrees. So that's where I get to 250 degrees. And the radius is 4. So,
I when I did this problem, that's how I approached it. And then I checked my answers in the back. And even though it labeled it S, it wanted us, at least in the back of the text, maybe the back of the text is wrong, it gave us the answer for finding the arc of the 110 degrees. It was very confusing because what is labeled S, like on a test, what is labeled S is what you should want to find, right?
yes. So, well, this is the answer that I'm getting, and I'm sticking with it. So yeah. if the back of the book is different, then I'm going with this. Okay. So yeah, change theta, 250 degrees, change it to radians. You must change it to radians, otherwise you get the wrong answer. So you multiply by pi over 180. Again, the logic is the degrees cancels the degrees. There's a degree on top and a degree on the bottom. They cancel out. So 250 over 180 divided up to 10, 25 pi over 18 radians. Now S is r theta. So r is 4. Theta is 25 pi over 18. I can cancel the 4 with the 18, leaving with a 2 and a 9. 2 times 25. So 50 pi over 9. They don't give me any units here. So they don't give me any units. You don't give any units. So again, this is considered the exact answer, 50 pi over 9. And you can punch in your calculator, that's 17.45 as an approximate solution. Okay, so this is considered inexact. Yeah.
I'm a little confused here. 400 over 8
divided by 9.
Oh, I see. Yeah. Okay.
Whoops. 17.45 roughly. Okay. Then 39. Find the area of the sector in the figure. So it's like a piece of pie, right? Just cut like so. How much area is here? So it's a fraction of the whole. 65 degrees, radius is 4. So 65 degrees, change the radians, multiply by pi over 180. Pi radians divided by 180 degrees. Both of these numbers are divisible by 5. So if I divide out of 5, I get 13. Divide this by 5, get 36. So 13 pi over 36 radians. Again, in reality, you don't even have to put the R. You don't want to. Right, so what's the area of my piece of pie? 1/2 r squared theta. 1/2 radius is 4, 4 squared. Theta is 13 pi over 36. Again, please notice it's got to be in radians, not in degrees. That's basically it. This is 16. Half of 16 is 8. So 8 times 13 pi over 36. Let's see, I cancel out a 4 here, right? Divide this by 4. Divide this by 4. So I have 2 times 13, 26 pi over 9. So, okay, this is considered the exact answer. And the approximate answer is what you get when you put it in a machine. Looks like I got 9.08. Show you that on my calculator, 26 pi divided by 8. 26 pi over 9, sorry. Messed up. 26 pi divided by 9. 9.08. 9.0757 rounds to 9.08. Yeah. Okay. All right, folks, I just have one more problem, 43, and then believe it or not, we're already done. So if we finish early, that's okay by me. Then next time we'll start 4.3, which is on right triangle trigonometry. So what's going on with 43? Okay, so yeah, after this, if anybody has any questions, you can bring it up. Otherwise, we'll be done in less than 5 minutes, more likely. And remember, there's no class tomorrow, school tomorrow. At the equator, the radius of the Earth is approximately 3,960 miles. Determine in miles per hour the speed at which a point on the equator is moving as a result of the Earth's rotation about its axis. Okay, so what are they talking about? So here's a picture. At the equator, radius is 3,960, and we're spinning around, right? Well, circumference is 2 pi r, circumference of a circle. So 2 times pi times 3,960 is so many miles. So if we multiply this out, the circumference of the Earth at the equator is roughly 24,881.41 miles. Okay. So circumference is 2 pi r. That's at the equator. Now, if we're higher up, like the San Francisco Bay Area, we're way up here somewhere, right? So to go around the world, that's obviously not as far as if you're down at the equator. And so 2 times pi times 3,960. 2 times pi times 3,960, 24,881 point blah, 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 roughly 25,000. So if you go all the way around the Earth at the equator, it's about 25,000 miles, 24,881.41. Okay, now they're asking for speed in miles per hour. Well, the Earth rotates once a day, once every 24 hours. So I simply just divide this by 24 hours for the linear speed. 24,881 divided by 24 is about 24, which is about 1,000. So it comes out to be roughly 1037 miles per hour. Okay, so if you're standing on the equator, you're spinning at about 1,000 miles per hour. I mean, you don't feel like it, but you are, just because you know the Earth is rotating, because you know the sun rises and sets. Apparently, if you weren't rotating, then of course, you know, you would just stay there, and the sun and the moon and the stars would all look exactly the same, but they don't. Right. So you're going roughly 1,037 miles per hour at the equator. All right. And that was pretty much what I wanted to show you today, folks. And again, so the homework is this, but again, homework is really in quotes because I end up doing a lot of the homework anyway, which means just go back and review it and you do the few problems that we have beyond that. Okay, I'm done for today, folks, 4.2. So I have a buffer day even for next time. So, but next time I'll get started on 4.3, I guess. So remember, no class tomorrow, no CSM classes at all tomorrow for flex day. Okay, let me check the chat. Something on a test, do I want the exact answer or the approximate decimal answer? Normally give the exact answer, but if you want to give me an approximate answer, that's okay too. But you should always give me the exact answer, like leave pi as pi, leave square roots as square roots, and so on. Okay. All right, I'm finished, folks. Let me stop the share and check the chat again. Anybody else want to ask a question? Otherwise, we're done for the day. All right, have a good day, everybody. Enjoy your one-day weekend tomorrow, and the next class is on Thursday. All right, okay. Bye, everybody.
Thank you. Bye. Thank you,
Thank you.
Professor.
Thank you. Have a good day.